Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good morning again. I'm David Martin, the Associate Director of the Applied Physics Laboratory at the University of Washington and Chair of the NANUS Board. And this is Dr. Jan Newton, the NANUS Executive Director.
Hello, I would just like to welcome you all here and share David's greetings to you all. We are honored by your presence. You're a numerous and diverse crowd, and I look forward to interacting with you more. Thank you.
Thanks, Jan. Thank you again, folks, for coming today. This is a quite important conference for our region, and as you'll see later on today, for this national effort on which we're all embarked. I see this as having three principal reasons why we're here today. One, to educate and inform a constituency in the Pacific Northwest about what we're about here with IUS and with NANUS, to hear from our users on how we are doing things and how we can do things better for two reasons. One, so we can do things better, and so that people who are not yet trained with us can understand how powerfully important our user base is to us. And third, to encourage and enable those federal, state, tribal, and local agencies which have missions involving the oceans who are not yet engaged to do so with us. I need to thank a number of people. I begin with the Interagency Ocean Observation Committee, and working with them, Ralph Rayner, Nicholas Rome, and Joshua Young, for all their Herculean efforts in getting this set up and for their role in leading this workshop. Also, our local organizing committee, whose members are listed in the brochure, which will be coming here soon. But if I could ask all the members of the local organizing committee for this workshop to please stand for a round of applause. Thank you all for that. And of course, our sponsors. I begin with Microsoft, and I also add Seabird Electronics, Sonodyne International, Reed Exhibitions, and Puget Sound Partnership. And I end my thanks where I began, with the wonderful generosity of Microsoft Research for providing this beautiful venue and all of the support that is entailed with a workshop of this magnitude. And it is my distinct pleasure in that regard to introduce to all of you Mr. Rob Fotland of Microsoft Research.
Thanks. Is this, am I on the mic? Yeah? Okay, fantastic. Welcome. First of all, I want to say that, and this workshop is about you, so I want to get to the about you part. I'm really very excited to be here and to be a participant and learn a lot today. And before I go into my little brief introduction about Microsoft and Microsoft Research, I'll re-emphasize, or I'll mention that we have sort of a follow-on event tomorrow, which everybody is welcome to attend. We have some pre-registration for that, around 45, 50 people. And that will be over in Building 99, so that's a different facility, and we'll have sort of an extended look at some Microsoft technology. If you're interested in that part, that would be a great way of getting connected. And then we'll have some follow-on discussions and work from today's proceedings. So very quickly about me and Microsoft and Microsoft Research and all this stuff. Microsoft Research is a part of the company that's sort of charged with looking ahead and thinking about the future of technology. And I feel very lucky to work in a part of that that's called Microsoft Research Connections. It's directed by Tony Hay, and it's about collaboration, strong emphasis on collaboration and on problems associated with, let's say, getting science done. And so we've published a book called The Fourth Paradigm, which is free online. You can look at that, and it's a way of thinking about problems that have arisen as our technology's kind of gotten ahead of us. And for example, you've probably had conversations about the data deluge, or you've had conversations about all the data sets that are out there that would be nice to have access to, and why can't we figure out how to do that with computers and make them discoverable. In fact, my group, my theme, which is directed by Dan Fay over here, is called Earth, Energy, Environment. So that's kind of our focus. And we're concerned with the full arc of data in informatics through the research process. And so this workshop kind of represents a foray for us into a slightly different space, because it's not pure research, but it's actually getting into the applications and the uses of data and the generation of data. So we're very excited about that, about learning more about that. When I say the data arc, I mean everything from imagining what your research project would look like or your application, to going out and acquiring the data, to accumulating it, collecting it, curating it, to making it available to your users, to possibly publishing it, to make it discoverable and reusable. And what we try and do in our collaborations is we try and make the solutions that we come up with to various pieces of this data arc, this informatics arc, not only useful for our collaborator, but also replicable so that other people can take a look at that and adopt it. And a good example of that would be something that we built called SciScope, and that is a one-stop shopping center. It's a data catalog. It's built on a map, and you can select a polygon and a time range and a keyword, and it will tell you whether or not there's data in that parameter space that you selected. And that's currently hosted at Berkeley Water Center. And once it's done that and shown you on the map where the data is available, you can click on one of those I have data icons, and you can tell it to go get the data. Now, it's going and getting the data from the U.S. Geological Survey, National Water Information System, but you don't need to know that. And you can also go get information on diazinon or other various waterborne toxic chemicals, and it's going and getting that from the EPA. So it's going to different agencies and getting data and acting as a single collecting point. So the concept there is, can you build a system that allows somebody to access public data without having to go to each individual data portal and have a different kind of interaction and figure out the data portal. So that's the kind of thing that we're interested in. Now, another part of the data arc that's really important is visualization, particularly as data sets get more complex. So I wanted to show something that we're working on right now. It's called Layerscape, and it's powered by Worldwide Telescope. Worldwide Telescope is running up here, and it was originally an astronomy tool. Now we're kind of re-evolving it towards an earth science focus. And the important thing to say here is that going into this, the idea is to try and demonstrate a slightly more complicated than usual data set and some tools that we're building into this system to help you visualize that, to get a handle on it. And this is freely available. It's something you can download, install, and run and play with and learn how to use. And there's more tools built around it, too. So I'll talk about that in a second, but I think that's probably enough initial talking. We'll see how this works. Hugely dangerous to try and do a demonstration, a live demonstration, but we'll see how it goes. Okay, so this is showing where we are. I need Jan to make this thing work. We're off the coast of California. This is a collaboration with the Monterey Bay Aquarium Research Institute. And this is showing a drifter that drifts with the current. It goes southwards for about 4 days. So this is an experiment in November of, I think, 2 years ago. And then there's a robotic submarine called Dorado that swims around it in circles and porpoises. It goes up and down. And every time it passes through the depth of the drifting package, we make a little ripple here in our visualization to show that they're at the same depth. And therefore, they ought to be seeing similar stuff. They're both CTDs, right? But the drifter is also grabbing water samples for metagenomic analysis at MIT. I set up all this data in an Excel spreadsheet and just pushed it into this application and hit play. Well, that's the initial visualization. Then once I had a handle on the data, I went back and I actually authored this tour, which is a series of perspectives and timestamps and some text and some music and so forth, so that I could show it to you. I think at this point we're going to go like underneath the data. So it's really a two-stage thought process. The first is, how do I get my data in here and look at it? And then once I understand my data from looking at it, how do I tell a story around it? And the guys at Embari saw this. The first thing they said was, oh, looks like our data is not quite calibrated. Because the colors should be the same. Every time you see those ripples, they should be the same color, if you're close enough. This happens to be salinity. I should have mentioned that, yeah. But they have a lot of stuff in their data stack. It's dissolved oxygen and a couple of fluorescence channels and so forth. Okay, but let's move on to something that's not geospatial necessarily. I have another research project that involves mass spec analysis of water samples. I'm going to turn this down a little bit. So this is a grad student's decomposition of both EAMS, so fluorescence results, fluorescence spectra, and then mass spec. And the point here is that this is an abstract space, right? And this is a decomposition of data into an abstract set of components. You don't need to have a latitude and a longitude to use this system to visualize these complicated data sets. And the last thing I threw in here just for fun, you have to sort of see if you can guess what this is. Any thoughts? There's no way in the world you're going to guess this. These are tweets of Happy New Year on New Year's Eve. So the nice thing about this is that the Happy New Year thing came about because we created a website for content. Okay, we've created these set of tools, and you build something and you want to share it with people. Well, you need something like YouTube. So we've built this sort of YouTube thing. It's a Layerscape website. In fact, I'll see if I can stop this. Okay. And I'll see if I can drag this over here. Boom. So that's the Layerscape website. You can hit play and see what happens there. But the point of the website is that you can create content with this system that I'm showing here, and then you can upload it here, and you can make a community, and you can share it with people, and then you can let anybody see it. So some people came along and they made that Happy New Year thing because they happened to mine tweets for latitudes and longitudes, and they saw our system, and they mashed it up, and off we go. So this is kind of the thing that we're really interested in seeing adopted right now, and that's why I'm showing it to you. It's kind of a lot of fun to work on. But before I quit, I'll mention a couple of other Microsoft technologies. One of them is Eye on Earth, and that's it's part of Microsoft that built it. It's our worldwide public sector. It's not Microsoft Research. But Eye on Earth is about accountability to the broad public. So the European Environmental Agency hired Microsoft to build a website that allows people in the European Union to go and report on water quality, report on air quality, report on noise levels, report it into this website through their phone, and then you can go to this website and you can see the density of data and what it's like at your favorite beach, what the historical record of how dirty that beach tends to be. Do I want to go swimming there? Okay. So Eye on Earth is something that we'll talk about extensively tomorrow at that follow-on session. And Eye on Earth is sort of merging with something called Data Market. And Data Market is a Microsoft Cloud resource for getting access to data. So these are really, really important sort of product-level technologies. They're not coming out of research. They're coming out of our product engine at Microsoft. And so it's potentially really valuable to a community like this to know about these things and to sort of be aware of the potential uses. So I think that's it. The last thing I'll say is that when you come to these things, people usually hand you a thumb drive with your company on it or something like that. And I noticed some of you have these epiphytes, so I wanted to point out that rather than give you yet another thumb drive, we were experimenting with handing out some actual really photosynthesizing creatures. They're epiphytes. They're available outside, and there's a little assembly process. You have a little spray bottle. They don't have any roots, so you just kind of keep them on your desk and hit them with some spray every once in a while. And there's an instruction sheet and a little sticker that you can make their landing pad, their home bee, and then there's the epiphyte itself. And you can choose one and bring it with you, and we'd love it if you carried it along, and you can even read the instructions and go register your epiphyte at a website and participate in the epiphyte community. It's all about social networking. So with that, I'll just say welcome again. We're so glad that you could come here. We hope this will be great, and I'm looking forward to what comes next. So thank you very much.
We do have time for questions, ladies and gentlemen. I got one.
Okay.
Is the product that you're showing here slanted towards a decision maker, would you say, or a basic or academic research community, or somewhere in between?
Yeah, so the Layerscape, the Worldwide Telescope, is really right now being built for researchers. Now, my philosophy is that we have this huge outreach potential, educating, as you say, decision makers and so forth. So every technical decision we make for researchers, I try and make there be a component in the direction of that outreach and that public policy space. So we're trying to, for example, in choosing names of categories, we didn't go for highly technical category names for how you would choose what to classify your content as. So that's basically our thing, was we're working with researchers. Broad focus is our eventual aim.
question. It's a little loaded, but I think most people in the audience know Microsoft as a company. You work for Microsoft Research, which is a subdivision. Could you just maybe tell us a little bit about what Microsoft Research really is respective to Microsoft?
Right. The question is, what's Microsoft Research with respect to Microsoft? And we are sort of the guys who get to think about what is the future of technology and in a lot of cases invent that future. Some of what research does has to do with sort of prototyping crazy ideas that could eventually become products, and that's how the Kinect human shape recognition game controller came about. That was originally a Microsoft Research project that got kind of incubated over or thrown over the wall into the product space, and it's obviously been hugely successful for us. So that's wonderful. But we also have just pure theoreticians, guys who are working in graph theory and all kinds of abstract spaces like that. And then, as I say, we have this sort of collaborational focus in our group where we get to go out and learn from and partner with people outside the company. So we have a lot of different focuses, but Microsoft Research in general is sort of the looking ahead part of the company. And we're not about turning a profit, which is why we offer the tools that we build like this completely free. And we're just trying to make a contribution. Yeah.
Rob, as you got introduced to the ocean observations community, as it were, and looked at the kinds of data that are being generated, I imagine at some point you said, gee, I wonder why they don't do the following or why there isn't the following kind of capability. I'm just curious what your first reaction was to looking at the ocean observations data community.
Well, the first thing you realize is the ocean's really big. There's not enough of us to canvas it, and so the data is very sparse, right? And so what you want to see, and this is not just oceanography, is you want to see the data that gets collected be available so that you have, let's say, data management organizations like BecoDemo at Woods Hole who are trying to pull together like NSF requirements for making your data available and people's requirements for how they like to get at data. And then this idea of a web service where I can write a computer program that gets data rather than having to go to a website and click around all the time. So not just in oceanography, but we see this evolution of data systems. And then, of course, there's OGC standards feeding into this. So this big process going along, and everybody sees the direction. They're headed the right way, in my opinion. But it's just really hard to do. So, you know, that's the direction that we talk about trying to help out and push forward a lot. Data system, data access. Yeah. All right. Well, I feel I should turn it over to our keynote speakers. So let me halt there.
Thank you, Robert.
Thank you.
The individual that's going to introduce our keynote speaker today is one of 3 federal co-chairs of the Interagency Ocean Observing Committee, which was brought into force by a national law in 2009, which established the requirement for a regional coastal ocean observation network for our country. He is Bob Houtman, who is the section lead for the Integrative Programs section within the Ocean Sciences Division of the National Science Foundation. Ladies and gentlemen, Bob Houtman.
Thank you, David. It's my distinct pleasure to introduce Ms. Laura Fergione, the NOAA Deputy Assistant Administrator for Weather Service and the Deputy Director of the National Weather Service. In this role, she is responsible for the day-to-day civilian weather operations for the United States, its territories, adjacent waters, and ocean areas. She previously served as the Assistant Administrator for the NOAA Office of Program Planning and Integration and was responsible for corporate management to coordinate the many lines of service for the $5 billion agency. Earlier in her career as the Director of NOAA's National Weather Service, Alaska region, she was responsible for all operational and scientific, climatological, meteorological, hydrological, volcanic ash, and tsunami warning programs for the state of Alaska and the surrounding waters. I think you will agree with me that Ms. Fergione is extremely well placed to provide insight on how the National Weather Service currently uses observations and the potential for new capabilities both for operational and planning purposes. Please join me in welcoming Ms. Fergione for her keynote address.
Technical difficulties. Are we wired? Can you hear me? Great. Perfect. Thanks, Bob. And thanks to Rob Fotland for his visual presentation. I obviously do not have cool visualizations for you like he does, but we'll work on it. We do have some cool weather for you today. I know it's like this here all the time, just like it's like this in Alaska all the time. And so we can thank our meteorologist in charge of the Seattle Forecast Office, Brad Coleman, for providing this wonderful weather we have here today. So, Brad, take credit for the good weather. Come on now. So it's my pleasure to be here. There were several people that twisted my arm a little bit. The first email I had was from Jack Dunnigan. Wanted me to come here and speak to you all, and then Stanka Willis, and then Jan Newton as well. So they didn't have to twist my arm very hard at all. I've been involved in IUCE basically since its inception, and I was a little nervous at first, not understanding what IUCE was all about, but as soon as Admiral Lautenbacher put out his annual guidance memorandum saying that IUCE was cool and something that we should really do, helping us take the pulse of the planet. And so I understood what was going on. Next thing, I met Molly McCammon, and I was hooked. So I was on the AUCE, the Alaska Ocean Observing Board, and everything else is history. So thanks to Molly for encouraging me to go to D.C. when that opportunity came forth, too. I don't know if she was tired of me or thought maybe I could help a little bit more in D.C. Our hosts, thank you very much, Microsoft Research. What a beautiful campus you have here. It's a great place to be. And also the co-sponsors. Again, I'd like to thank the co-sponsors, Seabird Electronics, Sonodarn International, Reed Exhibitions, and, of course, NANUS, the Northwest Association of Networked Ocean Observing Systems. Much easier to say NANUS and IUCE. And then we all joke about the oozing of all the regional associations, right? So we are facing interesting times, and we are increasing our understanding of the oceans, the atmosphere, the land, all the time. And this has led to excellent advances in our ability to forecast and warn the oceanic weather and the atmospheric weather for you all. But we don't always get things right. When I was in Alaska, I always had the weather right, though, because we hardly had any verification observations out there, so the weather was always right. Days like today, though, make me think of when I was an aviation forecaster in Alaska, and the photographers would call and say, "Here's the weather I need," and I would say, "Well, here's the weather you're going to get," and they would say, "Well, here's the weather I need." So we continue to struggle with knowing exactly what's going to happen with the weather, but partnerships like you all and through IUCE definitely has helped us advance our ability to forecast the weather. 2 weeks ago, Brad was not being applauded and clapped for when the Seattle area was hit with the winter storm and the ice storm. Snow on Wednesday and then turning over to ice on Thursday. So the storm actually wasn't a surprise, though. We were doing webinars and briefings over the weekend before the storm actually hit. There was uncertainty in the amount of ice we were going to receive, and that was really what the surprise was the magnitude of the storm and how long the storm was actually going to last. Our forecast models didn't anticipate, again, the magnitude of the ice. So the ice is what really fooled us, the private meteorologists and researchers. We did get back on track quickly using our real-time observations, the profilers, our new coastal radar, exciting to have that coastal radar out there showing us what was going on, and of course the automated system observing systems. We worked with Puget Sound Energy, and that's important to work with folks like Puget Sound Energy to make sure that their folks who were out trying to restore the power could do that in a safe manner as well. So they were facing dangerous high winds as they worked to restore the power to the thousands of customers who were out of power. It's always difficult to forecast here, just like in Alaska with the coastal terrain and the mountains. Back east, they say it's hard to forecast as well because of all those, well, they call them mountains, but they're kind of like those rounded hills they have back there. But it's definitely a challenge as well, particularly when you have storms coming off of the ocean, the nor'easters we have back in the east. And so, again, pinpointing those temperatures and other factors, whether you'll get ice, snow, or wind, is really important to have an understanding of what's going on over the ocean. Over the past couple of decades, investments in science, technology, strategic partnerships have enabled us to overcome some of the obstacles and greatly improve our forecasting. For example, IUS and NANUS now have in the water tremendous amount of information that's fed to our National Data Buoy Center in Stennis. In fact, I was down there visiting them last year, and the amount of data they have now is unbelievable and has improved significantly since the Indian Ocean tsunami, December 2004. Another great example, again, is the installation of the Northwest new coastal radar last fall. I saw some of the advances at Brad's office yesterday. I went to the weather forecast office and saw how that was able to show really where the rain and snow line was in the exact position. Unfortunately, that's the real-time data rather than being able to help us forecast it hours and days in advance. We've come a long way, but we have a long way to go. What else might have helped us with that ice storm? One thing we found almost immediately in the assessment that Brad and his office did was our models did not capture the extent of the precipitation that formed over the Pacific Ocean. It would help immensely to improve our atmospheric observations over the ocean. One of our major challenges is to integrate the ocean, the atmosphere, and our coastal observations at all scales. The new Doppler radar on the coast here provides advanced technologies in data collection. However, the radar can only see a few hundred miles out, and as you know, those storms are often developing and moving in from thousands of miles away out at sea. Integrating these multiple collection platforms, satellites, ocean observing systems, coastal buoys, high-frequency radar, that would significantly improve our predictive capabilities. Our partnerships have enabled us to integrate these capabilities, particularly the mutual benefits of our IUS partnerships and what that can bring to us in the future. There are strong national and international needs as well. You know, last year we experienced the year of extremes, we were calling it. Over 1,000 lives were lost. So we had 14 individual billion-dollar events related to weather. And those economic losses totaled $50 billion. Even though in the weather enterprise we are performing well, Joplin was really the catalyst for us in regards to developing an initiative called our Weather Ready Nation. We did a great job of forecasting the tornado that impacted the Joplin area. In fact, they had 24 minutes of lead time, but still 160 people perished. So why are people still dying if our forecasts are so good? Through strategic alignment of partners like you all, we'll be able to better get the information of these forecasts and warnings to the last mile. How can we communicate the information appropriately and minimize the loss of life and property? None of us can improve and provide the Weather Ready Nation initiative alone, so we've got to value our collaboration and the partnerships. The private sector research and innovation that Rob talked about, investments in new technologies and research institutions, all that add value to the work that we need to do, again, to build this weather-ready nation. I know that oceanographers often envy the meteorologists' wealth of observations, but meteorologists, particularly marine meteorologists, are always observation-starved. We want more observations, And the more we can get, the better our forecast and warnings will be. We have a couple paths to take. One is to continue doing what we're doing now, doing the same things. Ironically, it is Groundhog's Day today, and so Bill Murray may have had it right. But those of us that are here in this room, we're not going to accept doing the same things over and over every day. We're going to choose another path and push forward to continue to improve despite the constraints imposed upon us in these difficult economic times. We are all observation starved, but observing systems are expensive. That makes our partnerships all the more important, where we're not only leveraging each other's expertise, we're also eliminating redundancy, reducing uncertainty, and ensuring the maximum value for each system. So where are we now? Our current capabilities were fueled by your visionary decisions made in the past. Strategic partnerships and sophisticated instrumentation have resulted in our greater understanding of the interactions between the oceans and the atmosphere. And I'm so thankful that I'm talking to such a diverse group of individuals out here. Typically, I'm talking to a bunch of meteorologists. Sorry, Brad. But that's really what we've got to do. We've all got to come together beyond just the meteorology community and make sure that these partnerships are leveraged. And we're understanding better the linkages among the land, the atmosphere, and the oceans, and how these influence each other. IUCE observations provide data that enable Weather Service to run models and create marine forecasts, advisories, and warnings. In some regions of the country, all we have are wave observations. The forecast offices are provided by IUCE. Overall, NOAA National Weather Service platforms operated by IUCE partners and NOAA's National Ocean Service provide 78% of the data that the National Data Buoy Center has. So it's pretty amazing the amount of information we're able to compile and pull together. We in the weather enterprise are keenly appreciative of how knowledge of oceans has improved the meteorological modeling and forecasting. For example, Hurricane Irene, our track forecast was right on the money. We have greater lead time in understanding and detecting the storm development. In fact, the storm actually made landfall near Morehead City, North Carolina on Saturday. On Monday, we were trying to get Dr. Hayes on the flight of the P3 that would penetrate the storm. And I actually had to go on the website, the Hurricane Center website, and say, let's see, it looks like the storm might be named Irene. I think you're going to be flying into Irene on Friday, Jack. And that was the storm he flew. So that's pretty amazing that we knew that storm was out there 7 days in advance and pretty close, almost right on track to where it made landfall. Now, in 1999, I was the warning coordination meteorologist in Morehead City. That's when Hurricane Dennis, Floyd, and Irene, devastation has kind of followed me, so it's not really my performance, it's just that devastation has followed me along my career. At any rate, Hurricane Floyd in '99 almost took the same path that Irene took, but unfortunately, we evacuated Florida, Atlanta, South Carolina, North Carolina, all up the eastern seaboard, we evacuated. Thankfully, Irene, we knew she was going to pretty much go right into North Carolina, so the number of evacuations was considerably less, based on our ability to forecast the track, again, 7-8 days in advance. Another extremely important benefit is that we are able to avoid those unnecessary evacuations. Think about how information increased people's safety. Not only are we providing more time to prepare for storms that hit, we're avoiding, again, those unnecessary evacuations that are so costly. In addition to quickly developing weather events, oceanic information is also helping us understand longer-range phenomena. Our knowledge of El Niño and La Niña events, for example, is helping with predictions and with connecting individual weather patterns. These events that we've seen here in the Northwest are very typical of a La Niña event that we've been in for a year now and we are expecting to continue. The IUCE community in the Pacific Northwest have provided significant help regarding coastal hazards through the high-frequency radar network and other observation platforms. These observations, in conjunction with the National Weather Service meteorological data, give us improved capability to predict the fate and transport of hazardous spills, and improve the forecast for Puget Sound, for the Strait of Juan de Fuca, and the Columbia River. We still have to build these already strong partnerships. As we increase our knowledge of systemic influences, we also look at how we can optimize the mix of the observations. Currently, IUS bring partners together to enable access to buoy and meteorological data from academics, commercial, and other local providers. This happens partially through federal dollars, but it also leverages a variety of other funding sources, so it's not just federal dollars. This, of course, decreases the costs of our work, but again, provides that valuable information so we can have accurate forecasts and warnings. We capitalize on this even further. For instance, with the investment in IUS, buoys can be supported in strategic locations of key modelers. So when I was in Alaska region, the partnership that we had with Molly McCammon, we were able to move one of the buoys in Prince William Sound and make it a multi-sensor platform. Now granted, that costs a little bit, and so we can't do that throughout the entire network, but it is some things to continue to think about. I find it fascinating that in the future our model forecasts may be improved by physical and chemical oceanographic observations brought to us by fleets of salmon, seals, sea lions, amazing technological breakthroughs that we had never thought of before. Effective work in our partnerships can also help us understand and mitigate the impacts of weather phenomena on coastal ecosystems and economies. So I think our current need is still this vision of a weather-ready nation. We're always looking at how we can do better, no matter how well we're doing, because we recognize the impacts that weather forecasting have on people and our infrastructure. The ice storm caused power outages, canceled flights, which I think Stanka was prepared to sleep on the floor here in Seattle, she said, business closures, etc. People look into the forecast to make decisions affecting their safety and their livelihoods. We're excited about our partnership with IUS, what it's done, and what it can do for helping us build a weather-ready nation. The end goal is to help people make better decisions with better information, so again, we can save lives and livelihood. The Weather Service part is to provide accurate information and help people act on it, to make communities resilient to weather and environmental impacts. Being a weather-ready nation goes beyond preparedness for storms and climate issues. A high portion of the U.S. population, as you well know, live along the coast now. I think it's 51% of the population live within 17% of our land. It's clear that we need more information, more observations from oceans in order to protect lives and livelihood. A Weather-Ready Nation initiative enables integrated environmental services that support both healthy communities, ecosystems, in the support of NOAA's vision of resilient ecosystems, communities, and economies. The National Weather Service and other NOAA line offices are working in partnership with IUS to address weather-dependent events that impact the public health, the coastal ecosystem, and coastal commerce. Harmful algal blooms and hypoxia threaten aquaculture and commercial fisheries. Pathogens threaten our health, recreation, and public safety. So as I heard yesterday, let's get that beach closure out the day that we need the beach closure, not the day after we need the beach closure. These hazards, combined with other ecosystem stressors such as climate change, ocean acidification, threaten our lives and livelihood. IUS partnerships contribute critical infrastructure and observing capabilities that address these issues on the local, regional, national, and even international scales. An IUS coastal observing model testbed is under development with the aim to accelerate the transition of science and technology in the coastal hazard prediction. Life, health, property, and the environment can be better protected against storm surge, harmful algal blooms, and hypoxia as the testbed helps us put knowledge into operational services. Last week I was in New Orleans at the American Meteorological Society. So that's like our weather geek convention of the year. It is really cool. But I prefer the diverse community I have here today. But seriously, New Orleans is still recovering not only from Katrina, but also now from the Deepwater Horizon Gulf oil spill. During Deepwater Horizon, cleanup made very clear the cross-influences of weather, water, and the influences on people and the ecosystems. In fact, the Coast Guard said that weather drove their operations. The first thing they needed to know was what the weather was, so they could then determine what operations they took throughout the day to incorporate the rest of your expertise. The situation had major impacts on ecosystems, affecting commerce, tourism, and health. The cleanup required great efforts from a large number of partners. Workers capping the leak needed weather forecasts for lightning storms, hurricanes, and even severe heat. IUCE provided the high-frequency radar to track the movement of oil on surface currents. Industry's product innovations, such as the underwater gliders that we saw in the demonstration, provided data to track the movement of the oil through the water column. All this information was vital to effective decision-making during the spill. The National Weather Service is eager to continue this partnership. We also need our system partners, so I'm looking forward to this workshop to provide key information that will help get us closer to the vision of a weather-ready nation. A weather-ready nation requires regionally scaled collaborations and observations, data delivery, and product development. The needs don't stop at the regional or national levels. As I mentioned, we recognize the need for more data in the atmospheric observations over the oceans. Our National Center for Environmental Prediction, which is where the IUCE testbed will be, they are performing global ocean and atmospheric modeling and real-time data dissemination that enables IUCE research and regional and local modeling efforts. We continue to establish international partnerships as well for remotely sensed ocean data. The better our global observations, the better the benefits throughout the world. Again, taking that pulse of our planet. So in closing, the IUCE partnership has provided us with extremely valuable data. Maintaining the system and pushing improvements forward are important. Our collaboration is strong. Our partnerships include those with IUCE and the industry, giving us observations and together creating effectiveness in meeting our regional stakeholder needs. Most of the IUCE regional associations, which I know there are 11, work with the National Weather Service forecast offices. These collaborations provide data and model output for our forecasts, the delivery of buoy data through the National Data Buoy Center, and the joint development of products and services. IUCE is a strong partner, and we're pleased to kick off this workshop and explore how it and regionally NANUS can strengthen and optimize our efforts. I'm excited about this workshop and what it can accomplish to push our already strong collaboration and introduce new facets. I'm looking forward to finding new ways we can collaboratively build a weather-ready nation, and we need you to help us. Thanks again for allowing me this opportunity to speak with you this morning, and I look forward to building a weather-ready nation. Thank you. I don't think I've ever gotten a whistle before.
That is impressive. That is very impressive. So, Laura, you know, this is the first time I've ever met you, and I just want to say that I can't think of a better lead-off keynote speech for what you just delivered. I want to thank you personally. And to me, one of the things that you stressed so well was the complex interaction between ocean and atmospheres, which if you're a scientist, you get that, but I don't think that our world really understands that. The other thing you stress so well is the importance of partnerships, working together, and that's what this whole workshop is about. So your words are perfect. And the third thing that I love that you pointed out is that it is Groundhog's Day. And so let's think about how we want to go forward. So I just wanted to offer my thanks and now open it to the floor. We have plenty of time for questions for Laura.
So Puxatawny Phil did see his shadow. Granted, that's not incorporated into our INSO forecast, but it does mean that we'll have 6 more weeks of winter. And so I take Phil and the Farmer's Almanac. I grew up on a 5-generation farm in Missouri. And so I incorporate all that information into my weather forecast on a daily basis.
Laura,
Yes, sir.
Question, just a comment. I was the whistler I can tell you that. This is the strongest statement that I've heard from the Weather Service, and extremely valuable for the ocean observing community. And I just wanted to thank you for that leadership from the Weather Service. We've needed to hear that for a couple of decades. This is extraordinary, and I know many in the audience recognize that. I also realize many in the audience are just learning how important that statement is. So thank you for that statement. Really
Thank you.
appreciate it.
And I still have to go back to Admiral Lautenbacher giving us that leadership in that annual guidance memorandum 6 years ago or so, and also the relationship that I had with Molly McCammon in Alaska, and Molly encouraging me to continue my career beyond Alaska. I was an Alaskan forever, and Molly encouraged me to move to D.C. So we won't go down that path right now. But it is, I really understand. I mean, what is it, 4th grade, 5th grade, we learn about the water cycle. So it all has to come together from, where we say, the ridge to the reefs, or the summit to the sea, what have you. It all has to be combined. And one of the things, thankfully, I did go to work outside of Weather Service for PPI at NOAA, the Strategic Planning Office. And so it helped me better understand the other line offices within NOAA and many other agencies, EPA, DOI, and how we all need to come together, NSF, and work on these tough issues of combining the oceans, the atmosphere, and our land-based observation networks. Also, I did steal from PPI the coastal person who was working on fishery things, and I brought her over to the Weather Service with me to try to help get beyond the Weather Service and their stovepipe thinking just about land and atmosphere, and pull in the ocean components as well. So, thank you. There's a question in the...
How much has it hurt the atmospheric community in your forecasting that you don't have scatterometer winds over the ocean anymore?
I don't have percentages for you, but excitingly enough, I think we're working with India on ocean scat. Is that what it's called, Stenka? OSCAT or something like that. So I'm pretty sure we soon will have, what's that?
He wants a better acronym. OSCAT.
Well, coming from Alaska, yes, that does mean something different if it's warm or hard or what have you. But it is an important component. So particularly the focus on the loss of quickscat was always in regards to our hurricane forecast. Thankfully, we do have additional monitoring systems, and so we didn't see a degradation in our tracker intensity forecast related to quickscat. I think it's more in the polar regions, though, where we weren't able to see some of those hurricane force winds in our maritime forecasts. But again, we're continue to see advances in our satellites and other observation mechanisms to allow us to move forward. So coming from Alaska, when that situation was going on, it wasn't just about the hurricanes, it was about our fishing fleet in the North Atlantic and the North Pacific.
Another question?
It's correct that a number of the coastal WFOs have engaged well with IUS, but not all of them. What can we do to more comprehensively and institutionally integrate them into?
Smack them around, right? We just have to, there's so many things. Oftentimes, the warning coordination meteorologists and the SUs get really focused on the folks that they have relationships and the interactions that they've worked with over the years. And so there's only so much time in one day. And so we need to be more proactive and expand our partnerships that we have beyond just beyond just the meteorological and the emergency management community. During these extreme weather events, it's been difficult to focus on anything than just really surviving and getting past the next storm. But I will continue to push this, and through our social media and everything else, I know they were taking pictures out at the forecast office yesterday. We all have Facebook pages, and seeing that senior leadership is involved in a workshop like this alone will help, with the message of IUS is important, and we need to get further involved in these type of partnerships. So I appreciate your comment.
Any other questions? All right. Well, thank you again, Laura.
Thank
so
you.
much. the unpredictability of weather is a good segue to our next situation here. We had planned for 2 keynote speakers this morning. Senator Kevin Ranker from the state of Washington was to join us, and because of state legislature demands in Olympia last night, session's going very late, that was not possible. But we have Dr. John Stein here, the director of the NOAA Northwest Fisheries Science Center, who is going to introduce Senator Ranker and who we have asked to say a few words just to give you a sense a little bit for some of Ranker's efforts, but also to tell us about regional NOAA. So John, please join us.
Yes. Thanks. Thanks, Jen. So let me just get ready here. So first, I do want to thank Laura for her keynote address. That was quite good. So thank you, Rick, for calling her out, and certainly for your leadership at the Weather Service. Known Laura for a while, and she's a good friend and a good leader, and she does put that one NOAA hat on, which I think we all need and I think is important. And I think Laura was spot on in saying that collaborations and partnerships are the key to doing better and in achieving a weather-ready nation. And in fact, I think for all of NOAA's missions and responsibilities. So putting one of my other hats on as the lead for NOAA's regional collaboration team in the West, which is trying to work across the NOAA line offices. I just want to point out that the NOAA team here in Seattle and with its partners along the West Coast does work from another way, snow caps to white caps, and in trying to better understand the linkages between atmosphere and the ocean, how they affect our weather and climate, as Laura so aptly pointed out, and then how both affect our coastal environment and the living marine resources that are also important to our local economies. So better observations and improved understanding, I think glass half full will clearly lead to improved forecasts, projections, and on several fronts as we work together collaboratively. As Jan did note, Senator Ranker has been busy doing the business of the state of Washington and couldn't be here today. But I do want to make just a few remarks about Senator Ranker and why he was invited to give a keynote address. As just basic background, Senator Ranker represents the 40th Legislative District here in the state of Washington, which is north of here. He is also not only a strong and unwavering champion of NOAA and the work that we do with our partners, but he has a long history of promoting strong partnerships and collaborations at local and regional levels, including the work with NANUS. And I appreciate also being able to serve NANUS on its executive board and helping in building those collaborations. Many of you also may know that Senator Ranker has for many years a lot of experience in community development and in public policy in both the private and the public sectors. In addition to his responsibilities as a Washington State Senator, he is also a senior fellow for the Ocean Foundation and serves as a senior advisor to the Joint Ocean Commission Initiative. Senator Ranker has developed and advanced coastal and ocean policy, community development strategies, and conservation initiatives extensively on the West Coast, but also beyond in both Mexico and Indonesia. So in my current capacity, I've also worked closely with Senator Ranker as part of his leadership role on the National Ocean Council's Governance Coordinating Committee, which is helping with implementation of the President's National Ocean Policy. Senator Ranker has advanced key climate change legislation, coastal and ocean policy, and energy and transportation legislation. In Washington State Senate, he serves as Vice Chair of Natural Resources, Ocean and Recreation Committee, Vice Chair of the Agriculture and Rural Economic Development Committee, and a member of the Environment, Water, and Energy and Transportation Committees. So I think all these are important areas to the topic that we talk about today. So I will close with this. I've heard him state a number of times that there is no need to trade the environment for jobs, and that the two are inextricably linked. What is good for the environment is good for job development and growth, and I believe as many of us do, that he is absolutely right in this regard. And I think with that, Jan, I think it's a good place to stop and get on with the workshop. So, thank you.